Okay, most of this we already did in class. So our radical facts, we discussed the principal square root. Now, in this theorem, it states that the square root of A is equivalent to B, given that A and B are positive numbers. Such that B squared is equivalent to A, and the square root of 0 is equal to 0. All right. Now, I gave you guys an example here, and I said, oops, there we go. So I gave you the number 25. And I asked you for the principal square root of 25, and y'all said that was, well, simply 5, because 5 times 5, or 5 squared, is equal to 25. Okay? And when asked about the negative square root, well, simply y'all told me that's negative 5. Why? Again, because negative 5 times negative 5, or the same as negative 5 squared, is equal to 25. So it follows the theorem. So we continued, and I gave you 10. Now, 10, that is not a perfect square. But if we follow the same theorem, that would leave me with, well, the square root of 10. Because the square root of 10 times the square root of 10 is going to give me 10 again. So obviously the negative version would be negative square root of 10. Perfect. So let's talk about this term. I was a bit surprised. A lot of you guys did not remember this term, absolute value. So I gave you the example, what if I lived 100 miles south? Would I say I live negative 100 miles? Because, well, south is down, so that must mean negative. You guys immediately told me no, because the absolute value is talking about distance. It's the distance, so therefore it should be positive. A number is from 0. So let's take this example here. Draw us a number line. I'm going to make it a little bit longer, sorry. There we go. So let's try the absolute value of negative 2. So I would be looking for negative 2. Okay. And obviously, this is my main one here, so I think I'm going to put it up on top. There's my 0. So I'm going to start at 0, and I'm going to count the distance -2 is away from 0. So that's 1, 2 units. So I would say that the absolute value of -2 is 2 units away from 0. Okay, well, let's try another example then. Let's try the absolute value of 4. Okay, there we go, right over here. So let's start at 0. Get that really big here. So that would be 1, 2, 3, 4 units away from 0. Now, this would be true for any real number the square root of a squared is equal, as long as it's real, to the, and I'm going to make this kind of dark here, the absolute value of a. Okay, so let's try an example here. Let's try the square root of 3 squared. Well, that would be the absolute value of 3, which the absolute value of 3 is simply, well, 3. Okay. Well, what if I asked for, or what if I gave you the square root of, I'm going to use parentheses, -5 squared, just like the example that we had up here. Well, that would be, and you have to be very cognizant of the parentheses, the absolute value of -5, which the distance that is from 0 is simply 5 units. Okay. So now let's talk about cube roots. Okay, so cube root. The cube root of a is equal to b. Very similar to our principal square root, such that b cubed, which is equivalent to, of course, b times b times b, and it's equal to my radican, a. Let's see, I think we can fit this example here. Let's say I have the cube root of 8. Well, that's equal to 2. But why? Because 2 times 2 times 2, which is the same as 2 cubed, is equal to my radican, 8.